Diagram of a convex lens. Diagram of a convex lens. We have to draw a diagram of a concave lens. This is a concave lens. It should be a double concave lens. This is a concave lens or double convex concave lens has which has two concave spherical surfaces. We can denote the aperture. The vertical straight line xy is the aperture, and this horizontal straight line is the principal axis of the concave lens. This horizontal line is the principal axis of the concave lens, and we can denote the aperture of the concave lens. This vertical straight line xy is the aperture of the concave lens. Aperture means the effective diameter of the transmitting area of the lens. Now we can denote the optical center. O is the optical center of the lens. O is the optical center of the lens. Optical center of the lens. O is the optical center, that is O, and we can denote the ray or incident ray of light that will be incident or that will be refracted through the lens. This is incident ray of light. With respect to the incident ray of light, we can decide which spherical surface of the lens will be first spherical surface. This is the first spherical refracting surface of the lens on which the incident ray of light is incident. And we can denote the second refracting surface. This is also concave surface. This is the second refracting concave surface through which or from which the ray of light will emerge. C1 is the center of curvature of the first refracting surface, and C2 is the center of curvature of the second refracting surface. We can denote second principal focus F2, and also this is the first principal focus. F1 is the first principal focus of the lens. F1 is the first principal focus, which is the midpoint of optical center O, and C2. C1 is the center of curvature. C1 is the center of curvature of the first refracting surface. C1 is the center of curvature of the first refracting surface. F2 is the second principal focus. F2 is the second principal focus of the lens, that is the midpoint of optical center O and center of curvature of first surface C1. F2 is the second principal focus. Similarly, C2 is the center of curvature of the second surface. C2 is the center of curvature of the second surface. If second surface is an arc of a sphere, in that case C2 is the center of curvature of that refracting surface. F1 is the first principal focus. F1 is the midpoint of optical center O and center of curvature C2. This is double concave lens, and here the vertical straight line xy. The vertical straight line xy is the aperture of the lens. xy is the aperture of the lens, that is the effective diameter of transmitting area of the lens. The horizontal straight line connecting the two centers of curvature, that is C1 C2, is the principal axis of the lens. C1 C2 is the principal axis of the lens. O is the optical center. O is the optical center. If a ray is transmitted or refracted through the optical center, there will be no deviation of ray of light. Ray will be transmitted to the lens if it will pass through the optical center without any deviation. O is no deviation point, actually optical center, and F2 is the second principal focus. F2 is the second principal focus of the concave lens, which is the midpoint of optical center O and center of curvature C1. F2 is the second principal focus, which is the midpoint of optical center O, which is the midpoint of optical center O and center of curvature C1 of the first refracting surface. Center of curvature C1 of first refracting surface of the concave lens. F2 is the midpoint of optical center O and C1 or center of curvature of first refracting surface. C1 is the center of curvature of this first refracting surface. Now f1 is the first principal focus. F1 is the first principal focus of the lens, which is the midpoint of optical center O, which is the midpoint of optical center O and center of curvature C2 of the second refracting surface. F1 is the first principal focus, which is the midpoint of optical center O and center of curvature C2 of second refracting surface. Second refracting surface, which is the first principal focus. F1 is the midpoint of O and C2. O and C2. Now we can denote the different distances. We can denote the different distances with respect to this concave lens. If small f is the focal length of the lens, we can denote the radius of curvature of the second refracting surface. This is R2. R2 is the radius of curvature of the second refracting surface, and R1, and this is R1. R1 is the radius of curvature of the first refracting surface. First refracting surface. And here we can denote the focal length of the lens. Focal length of the lens. In this case, f is the focal length of the concave lens. F is the focal length of the concave lens. F is the focal length, that is the distance of second principal focus from the optical center. F is the focal length of the concave lens. Focal length of the concave lens, under bracket, the distance of, under bracket, distance of second principal focus. Distance of second principal focus of distance of second principal focus from the optical center, O, that is the focal length of the concave lens. Focal length of the concave lens. F, this is the focal length. F is the focal length, which is the distance of F is the focal length of the lens, distance of second principal focus F2 from the optical center O, that is focal length, and focal length is measured in the opposite direction of incident ray of light. R1 is the radius of curvature of the second refracting surface. Radius of curvature of the second refracting surface. Radius of curvature of the second refracting surface. This R1 should be the radius of curvature of the second refracting surface. This is the radius of curvature of second refracting surface, and R1 is the radius of curvature, of first refracting surface. Radius of curvature of first refracting surface.